This is a continuation of Lesson 1-6. This is absolute value inequalities that we're solving rather than equations. So to help you remember how to set up these inequalities, I have a little suggestion here. So we're doing greater than absolute values, and the little phrase greater will help you hopefully remember that a greater than absolute value inequality is an or statement, and then less than is to help you remember that a less than absolute value inequality is an and statement. Okay, so first of all, greater. Absolute value inequality that's written as the absolute value of x is greater than 5 means that it's rewritten as x is greater than 5 or x is less than -5. Now, why does that make sense? Well, absolute value is distance from 0 on the number line. So if you want numbers that are more than 5 units from 0, you will need to be either to the right of +5 or to the left of -5, because you want to be more than 5 units from 0. So you're either to the right of +5 or you're to the left of -5. And that's what those two inequalities are saying. They're saying that if you have the absolute value of x is bigger than 5, that can be rewritten as two inequalities with an or in the middle. One of them is the same symbol with the same number. The other one, the symbol flips and the number flips. So greater than the positive number or less than the negative number. So filling in the rest of the blanks down here, absolute value greater than a positive number is going to have to be to the right of the positive value, in this case 5, or to the left of the negative number, which in this case would be -5. Now, the graph of an absolute value that's greater than, if this is a positive number, the graph will always be 2 rays going in opposite directions. Okay, absolute value greater than is going to look just like you see up above. Your answer should be 2 rays going in opposite directions. So let's jump down here to problem number 2 and try one that's a greater than. So first of all, you want to pay attention to the fact that the absolute value is by itself. Okay, you want that to be alone, which it is. The second thing you want to pay attention to is the fact that this is a greater than symbol. So again, think greater. A greater than absolute value is an or statement. So if you want to be more than 30 units from 0 on the number line, then you want to either be to the right of +30, or you want to be to the left of -30. And you cannot be both. This word or in the middle there is important. It has to be there for your setup. So again, for the setup, one side is going to match exactly the inequality that was given, and the other one is going to be a less than or equal to. It's flipping the symbol and it's flipping the sign of the number. This is for or statements for greater than or equal to a positive number. So now we're ready to solve. So we're going to subtract 9 on both sides on each of those inequalities. And then we have a is greater than or equal to 21, or a is less than or equal to -39. Now, when you put that in set builder notation, it's going to be the set of all, and this should say a, the set of all a, such that a is greater than or equal to 21, or a is less than or equal to -39. Now, because it's an absolute value, we know that it's going to be, and it's a greater than, we know that it's going to be 2 rays going away from each other. Now, make sure when you put it on the number line that you make it make sense, right? Negative 39 is smaller than 21. So even if you write it this way in your set builder, make sure that when you go to graph it, that it makes sense. So we're going to have closed circles on both negative 39 and on 21. Okay, and then we're shading to the right of 21 or to the left of negative 39. So our graph is here. Now again, a greater absolute value greater than a positive number or greater than or equal to a positive number is always going to be 2 rays going away from each other. Okay, next we're going to talk about the less than absolute value inequalities. So I want you to think of the phrase less than. Okay, less than. So when you have an absolute value with a less than symbol, with a less than a positive number, the way that it gets rewritten is it's saying x is stuck in between -3 and +3. Now the reason that makes sense is because absolute value is distance from 0 on the number line. So if you want the distance from 0 on the number line to be less than 3 units, here's 0, that means you want to have the numbers in between -3 and 3. So it would be all the stuff in the middle here, in between. Okay, and statements where it's less than, absolute value is less than a positive number, the and statements will always have a graph that's a segment. Okay, and again, think of this as the x value lies in between. It's stuck in between -3 and 3. Remember we talked about how these symbols should face the same direction? And I would generally put the small number on the left and the big number on the right. And then the symbols, the terminology will make sense and the graph will look like a segment. Okay, we're going to jump down here and look at problem number 1. So first of all, you want to verify that the absolute value is by itself. You want to verify that this is a less than problem and that we have a positive number on the other side. Okay, and again, think less than, which means it's an and statement. And statements means when you take away the bars, you replace it with one side is less than 8, it matches. Okay. The other side, we're going to throw in a -8 there. So the less than ones are always, the absolute value part is stuck in between the negative and the positive of the number. Okay, and then we're just solving it like we talked about before. So we're going to subtract 4 from every part. And then we'll have -12 is less than 3x, which is less than 4. Then we're dividing through by 3, because we're trying to get x by itself in the middle. So we divide through by 3. We're going to have -4 is less than x, which is less than 4/3. Okay, in set builder, that's the set of x such that -4 is less than x, which is less than 4/3. Now, 4/3 is 1 1/3. All you really have to know is that it's a positive number, so it's bigger than -4. So here's 4/3. And then this notation says we're going to have open endpoints on -4 and 4/3, and we need the values that are stuck in between them. So it's going to look like that. Okay, when you start the problem, you think, okay, this is a less than, and that means that the graph will be a segment. So when I start the problem, I kind of know how the graph is going to turn out. And because I know it needs to be a segment, that's how I know that I should set up the problem with the absolute value part stuck in between the two values. So I'm going to stop there. You will have some assigned problems from the book, so you do not need to do problems 3 and 4 at the bottom of this page. We'll pick that up tomorrow.